Hello, ladies and gentlemen. Welcome back to Math 20-2, Chapter 1, Section 4, Proving Conjectures, Deductive Reasoning, Part 2. Now, remember with deductive, it's a little different. We have a theory. Then we come up with a hypothesis, or educated guess, then we do some observations or collect evidence, then we confirm it or not. So, and I talked about two-column proofs. I'm going to skip this one because it's kind of dumb. So, n is a number like 1, 2, 3, 4, 5. A formula for all even numbers is 2n. A formula for all odd numbers is 2n plus 1. Now, these are definitions. I don't know if you should know. Anyway, going over them just in case you don't know them. So, write down any two consecutive numbers. So, any two consecutive numbers would be like 10, 11, 6, 7, 41, 42, 191, 192. Now, here, I want you to note, if we did it for any number, I could just simplify or cheat and go 2n and 2n plus 1. All right, now, so far so good? Now, write down any two consecutive odd numbers. So, odd number would be 3. The next odd number after that would be 5. Now, consecutive means in order. Okay? So, 3 and 5, 19 and 21. But here, the important thing be 2n plus 1. And then the next odd number would be 2 more than that, or 2n plus 3. Okay? So far, so good? Now, write down the sum of an even number and an odd number. Well, an even number is like 6, and an odd number is like 11. That's 17. Okay? Or don't have to be consecutive. They can be like 132 plus 5, 137. Now, notice they're both odd. Are they all odd? That's a very good question. Because an even number is 2n, and an odd number would be like 2n plus 1. And notice that's 4n plus 1. Now that's 2 times 2n, which is an even bit. But this 1 at the end makes it odd. So they'll all be odd numbers always. Right? Now, write down the difference of the square of a number and the number itself. So the difference of a square and the number itself. So that's like 17 squared minus 17, or 6 squared minus 6. Now, generically, that's n squared minus n. Okay? Okay, so we can write out numbers, or we can write out generic numbers. Now, for anything. That becomes really important when we do mathematical proofs in a few minutes. So, the sum of 3 consecutive numbers, 66 plus 67 plus 68, 201. All right? So that's going to be some number plus 1 more than it plus 2 more than it. So that is 3n plus 3. It's going to be odd. So, the sum of 2 consecutive even numbers. So that would be 16 plus 18, which is 34. So that's n plus 2. That's 2n plus 2, which is even, because it's divisible by 2. It's going to be always even. Okay. The sum of the squares of an even number and an odd number. The sum of the squares. Okay. So I'm not looking for, sorry, I'm looking for patterns here, and I wanted you to be able to turn this into generic numbers. So, I don't know, 18 squared plus 3 squared, 324 plus 9, which is 333, I think, which is odd. Now notice that's 2n plus 1 times a different 2n plus 1. Now, if you want to get picky, sorry, plus, sorry. Oh, sorry, an even and an odd, sorry. Read the question, Mr. Sutton. An even is 2n, and odd is plus 1. Now what happens when you FOIL that or multiply it out? Well, this is a sucky example. I'm going to go on to something easier. The product of an even number with an odd number. An even number like 6 and an odd number like 7 is 13. But what is it for any even plus any odd? Well, any even number, product. God help me. I'm sorry, ladies and gentlemen, I'm getting old. 6 times 7, 42. I know. I can hear you screaming at me through the microphone. That's even. Now, does that always work? Well, like I said, back in 1.2, 1.3, we could just try to find a counterexample. So we could list all of them. 24 times 21 is 504. That's even again. But let's do the generic one. So as I said, the generic, even 2n. Actually, let me change colors. So your even number is 2n. And your odd number is 2n plus 1. Remember, we don't care about the n's. They're just whatever. Now we FOIL this. Remember foiling 2n? So that's 4n squared plus 2n. And note here, we can factor out a 2. So it becomes 2n squared plus n. Yes, we can factor out an n, but if we can factor out a 2, every number will be even. So it doesn't matter. I just proved for any even number times an odd number, the product, when you multiply it, will always be even. You could spend the rest of your life trying to find a counterexample, and I guarantee it, you will not find a counterexample. Because I just did it for the generic one, and it works for everything. So the product, sorry. So let's do this a little slower. Sorry, Math Geek and me's coming out. For 2 odd numbers. So the product of 2 odd numbers. 23 times 13 is 299. So that's odd. Are they always odd? Well, what I need you to be able to do multiply this out. So 4n squared. Yes, we're doing some math. It's 2n plus 2n. I know this section sucks. Anyway, plus 1. All right. So this is 4n squared plus 2n, sorry, plus 4n. So that's going to be odd. All right? So it doesn't matter. Anytime you multiply 2 odd numbers, the answer will always be odd because it's something plus 1. And I just proved that for everything. If you want to spend a few minutes doing counterexamples, go for it. Waste some time. I'm old. I'm not going to. All right? What I'm going to do is going to pause the video here and let you think about it a little bit. And remember, these are the definitions. Consecutive, so even number, odd number, consecutive. And we FOIL them out. Now, sorry, next part of the video, we'll use all these definitions in 2-column proofs. All right? But I'm going to be quiet now and let you think about it. If you've got a question, shoot me an email. Otherwise, good luck.